Welcome back, everybody, for another deep dive. And today we're going to be looking at something a little bit different from the online encyclopedia of integer sequences, or as I'm sure most of you know it, the OEIS. Specifically, we're going to be looking at sequence A0000059.
Yeah, the OEIS is a pretty amazing resource. I mean, it's this gigantic database of integer sequences, and it's been incredibly useful for research in mathematics and computer science.
Absolutely. And the thing about this particular sequence that really stood out to me is that it's made up of numbers, let's just call them K, where if you calculate 2K4 plus 1, you always end up with a prime number.
Yeah, that's a great point. It's not immediately obvious just from looking at the sequence, though, is it? You look at the first few numbers,
No.
you got 1, 2, 3, 8, 10, 12, and it's not like some simple pattern like you see in arithmetic or geometric progression.
Yeah, exactly.
Mhm.
So how do we actually figure out what numbers belong in this sequence? There's got to be a more systematic way to do this, right?
You're absolutely right, and that's where the formula for this sequence comes in. The formula is AN equals A000, where 68 n plus 1, 2 for n greater than or equal to 1.
Okay, hold on a sec. Now we've got another sequence, A0000068, popping up. What exactly does that represent?
So A0000068 is also a sequence in the OEIS, and this one is made up of numbers K, where K4 plus 1 turns out to be a prime number. So you can see how these two sequences are kind of related. They both involve generating prime numbers, but they use slightly different formulas to get there.
Okay, I see the connection now. So to figure out a number in our A0000069 sequence, we have to refer to this other A0000068 sequence. That sounds a little complicated. Can you maybe walk us through an example to make this clearer?
Sure thing. Let's say we take n2. So if we plug that into our formula, we get A000000682. And if we check the third number in sequence A0000068, it's 4. So that gives us A2422 equals 2. And if you remember, 2 is indeed one of the numbers in our original sequence, A000000059.
Oh, right, because 22.4 plus 1 is 257, and 257 is prime. So we essentially use the A00068 sequence as a sort of intermediary step to generate a number in our A0000059 sequence.
That's exactly right. The source actually gives another example, which is interesting. If we set n1, we get a1 is 000000682. Looking up the second number in A0000068, we find it's 2. So A1 equals 22 equals 1, which again is in our sequence A0000059.
Okay, I'm starting to see how these two sequences kind of work together to generate these prime numbers in these interesting ways. It really makes you think about all the different ways you can manipulate these numbers.
Absolutely. The fact that we can use one sequence to sort of bootstrap another one, and they're both tied into generating prime numbers, it really shows you just how interconnected mathematics can be.
Well, speaking of interconnectedness, our source also mentioned a connection to yet another sequence, A0378696. Now, this one focuses on prime numbers. It can be written in the form n4 plus 1. I mean, is this just a coincidence, or is there something more going on here?
Oh, it's definitely not just a coincidence. This connection really brings out a subtle but important point. You see, our sequence, A0000059, it deals with the numbers that give you a prime number when you use them in that 2K4 plus 1 formula, right? But this A03786 sequence, that one actually lists out the prime numbers themselves, the ones you can write as n4 plus 1.
So they're both kind of circling around this idea of prime numbers that you get from using fourth powers,
Yeah,
just from slightly different perspectives.
exactly. A0000059 gives you those K values, and A037896 gives you the actual prime numbers you end up with. It's these kinds of connections that make number theory so fascinating.
Yeah, it really shows how you can have these seemingly different ideas that are actually deeply connected. And I know we've got a lot of listeners out there who are into STEM stuff, and I bet they're already thinking about the applications of all this, especially when it comes to prime numbers.
Oh, absolutely. Prime numbers are incredibly important in a lot of fields, especially in cryptography. A lot of the security we rely on for things like online transactions, it all comes down to how hard it is to factor large numbers into their prime factors.
Yeah, it's pretty mind-blowing how these abstract mathematical concepts can have such a huge impact on the real world.
It really is. And this is just scratching the surface, really. Prime numbers also play a big role in things like coding theory, hashing algorithms, even random number generation. Understanding these sequences and how they relate to prime numbers, it can really open up a whole new level of understanding in those areas.
Before we move on, there's a question I've been wondering about. Does this sequence, A0000059, I mean, does it just keep going forever? Are there an infinite number of numbers that work in that formula? Or is there some sort of largest number that satisfies the condition?
That's a great question. And honestly, mathematicians are still trying to figure that out. There's no definitive answer yet. It's still an open problem in number theory.
So we've stumbled onto a real mathematical mystery here.
Exactly. And that's what makes number theory so exciting. There's still so much we don't know, so much left to explore and discover.
Makes you wonder if one of our listeners might be the one to crack this mystery someday.
I wouldn't be surprised. The OEIS is like a treasure chest full of mathematical wonders just waiting to be found. Who knows what other connections and patterns are hiding in there?
Wow, this deep dive has really given us a lot to think about. We started off looking at this sequence, A0000059, this list of numbers that lead to prime numbers when you use them in a certain way.
Yeah, and as we went along, we found this really interesting connection to another sequence, A00068, which is like a key to understanding how to generate numbers in our original sequence.
Right. We also talked about how it's connected to A03796, which shows just how closely related all these different ways of looking at prime numbers can be.
Absolutely. It's these kinds of connections that really demonstrate how complex and fascinating number theory can be. Even something that seems simple on the surface can have all these layers of depth to it.
And the fact that there are still unanswered questions, like whether ED000059 goes on forever, it just adds to the mystery and intrigue of it all.
It definitely does. It's a good reminder that even in a field like mathematics where we've learned so much, there's always more to uncover and discover.
Well, to all our listeners out there, especially those of you who are into STEM, I'd really encourage you to spend some time exploring the OEIS. You never know what you might find.
I agree. As we've seen today, looking at these sequences can give you a whole new understanding of the fundamental building blocks of mathematics and how they're used in all sorts of fields.
So thanks for joining us on this deep dive into the world of integer sequences and prime numbers. Until next time, keep exploring and keep asking those tough questions.